Yes, Madam Sylvia, what is the relationship between marginal product and average product? This topic is relatively new. Okay, we did this topic in July, June. So I believe we still remember the concept. So I just want to see those who still remember. Yes, Mr. Chimonia, marginal product and average product. Or maybe before we even go to the relationship, maybe we define these two terms. What is the definition of marginal product? And what is also average product? Mr. Emmanuel, what is marginal product and what is average product? Let me even get the graphs as we are trying to remember these things. Mr. Kasono, maybe you can help us. What's the definition of marginal product and average product? Good evening. Yes, I can. Oh, I even forgot to introduce the topic. This topic, colleagues, now here we're in the production theory. Just hold on, sir. Just hold on. Just hold on. Sorry. Yeah, colleagues, right now the topic we're in is production theory. Yes. Okay, Mr. Chimunya, you can go ahead. Yes. Mm-hmm. Uh-huh. Yes. Because marginal means additional or extra, right? Yes. Colleagues, are we all okay with that definition? Okay, then average product, sir. Yeah. So what you're complicating things. Um, Average output per unit when average product, this is just think of it like one product basically. Okay, the product one worker can make. Okay, average is per unit, so it's one. Think of it as in terms of one unit. So now, what is the relationship between marginal product and average product? Okay, you saw an example of the graph between the two. So what can we say? Should I beam the graph so that we see it again? What? Okay, here, colleagues, This question you did it as a groups. I don't know why no one is saying what they were so when you are discussing as groups, you never discuss the answers. The relationship between marginal product and average product. Uh-huh. Yeah. Although you at one point you mix them up, but yes, there's one point where you mix them up. Yes. Uh-huh. That's why you're mixing up, Mr. Vincent. Where you say it, where it crosses the marginal product line. Yes. What you're supposed to say is now when marginal product is less than average product, then average product starts reducing. But thank you for your contribution. At least I believe we've got the concept. So, colleagues, remember. Hmm? Yes. So, when marginal product is great, oh, you're okay. Yes. Mr. Vincent, thank you. Okay. Yes. So, when marginal product is greater than average product, then average product is increasing. As we can see in this diagram here. Okay. Marginal product from this point going to the left through this point, marginal product is greater than average product, and this average product is increasing. Then at this intersection, when marginal product is equal to average product, then average product is at its maximum. Then when marginal product is now less than average product starts reducing. Don't worry, I'm typing it out, madam. Please remember this. From today till you write the exam, those doing BBA, you will still need to retain this memory. Okay, but if you're doing accounting and finance, in the balance sheets, there's no marginal product or average product, so you can forget this. Yes. So when marginal product is greater than average product is increasing. When marginal product equals average product is at its maximum. And when marginal product is less than average product is reducing. Okay. Um, can you kindly type, sir? You are breaking. Just maybe type your question. You are breaking, so I can't hear you. Yes, type out your question. Then anybody else with a question before I go to the next part? What was the second part of the question? Because here I'm saying, so when marginal product is greater than average product increases. When marginal product is equal to average product is at its maximum. When marginal, yeah, share the question, Pep, because I think the first question I didn't, I didn't write it down. So let me see what it's saying. Yeah, just share the question paper. I open it up. These are just the solutions here. So let me know once you've shared it in the group. As we are waiting for you to share that one, maybe I can explain this table here. Because I believe in this table, you're supposed to get marginal product and average product. I think this is where there was that debate for if this one has to be blank or not. Do we remember this one, colleagues, when we had that debate? Yes. So here we're assuming they haven't put a zero in that question, okay? That's why we've put 50 here. Okay, colleagues? Because they, okay, does it share the question? Okay, so yeah, explain the relationship between marginal product and average product. What happens to average product with marginal product is greater than average product? I could answer from here. Average product is increasing when marginal product is equal to average product. Average product is at its maximum. Marginal product is less than average product. Average product is reducing. Okay. Part B, the table. Uh-huh. You need also to be relating this with the law of diminishing marginal returns too. Yes. I'll send this document with that one where the answers there. I'll resend it so you can see everything you need to put. That's okay, Mr. Vincent, right? Sure, sure. The table below shows the output of tomatoes in kilograms based on the number of laborers hired. Complete the table by calculating the average product and marginal product for each level of labor from 1 to 6. Okay, so we have to first calculate the marginal product. All right. So at 1 unit, because remember, at 0 units, total product is 0. So, and the formula for marginal product is this: MP equals TP2 minus TP1 divided by L2 minus L1. Okay. So here at 1 unit, the marginal product, since at 0 units, so TP1 will be 0, TP2 will be 50. At 0 workers, L1 is 0, L2 is going to be this one. So that's why we're going to put a 50 here. Are we all okay with this, colleagues? When you assume there's a 0 here, 0, 0 here, that's where marginal product is dash here. So marginal product, this will be your total product 1, this will be your total product 2. So 50 minus 0, 50 over 1 minus 0, 1. So 50 over 1, that's how you get this 50. Are we all clear with this, colleagues? Are there any questions? Mr. Chimonia, you were against this last time, you and Madam Geraldine. Are you okay with this now? Okay. Okay. So marginal, we get our marginal product. So you're going to say 120 minus 50 you're going to get 70. 180 minus 120, you're going to get 60. 220 minus 180, you get 40. 240 minus 220, you get 20. 240 minus 240, you get 0. Colleagues, any questions on these figures that are found? We are applying this formula here, but we know that our denominator, since the labor is increasing in units of 1, so our denominator all the time is going to be 1. That's why I'm just simply subtracting like this. If these units here for labor, if they're not increasing by 1 unit, then we would have applied this formula here. If maybe say 1 worker, 3 workers, 5 workers, 7 workers, then we would have I would have to be showing everything on that formula. Yes. Then average product, colleagues, what's the formula for getting the average product? AP equals what? Total product over, yeah. So here, 50 divided by 1, 1. 120 divided by 2, 60. Oh, 50 divided by 1 is 50 here. So I was even surprised. That's a big jump from 1 to 60. That's a big jump. 60. 180 180 divided by 3, 60. Okay. 220 divided by 4, 55. Huh? Colleagues confirm. Is it 55? Okay, 55. 240 divided by 5, 48. 240 divided by 6, 40. Huh? Yes, colleagues. Any questions? At what level does diminishing marginal returns begin to set in? Justify your answer with reference to MP. Before I give the answer, yes, colleagues, how will you know where the law of diminishing marginal returns begins? Like yesterday, here's a hint. Yesterday, how did we know when the law of diminishing marginal utility started in that other question? Yes? Yes? Madam Chabala? Yes, when marginal pro yes, yes. When marginal product starts to drop, that's where the law of diminishing marginal returns kicks in. Okay. So at 3 units, that's where it drops. Okay. So let me type this out. It happens at L equals 3. The law. Hold on, colleagues. That's me. Let me answer. Let me answer. That's what. Okay, pick up. Hello? Yes. It's ready. Okay. Okay. Where were we at? Yes. The law of diminishing marginal returns begins when the marginal product starts to drop. And colleagues, what is the law of diminishing marginal returns? What is the law of diminishing marginal returns? Sometimes the other name is the law of variable proportions. Okay, that's the other name of it. That's the other name they call it, the law of variable proportions. Yes, Mr. Chimonyo, law of diminishing marginal returns. Mm. The marginal product will decrease, then the total product will eventually decrease. Let me just take you back to these graphs again. This region here in green, this is the point where marginal product is increasing. Okay. We also have to remember the relationship between marginal product and total product. Okay. Then after we end this relationship, we apply it to the law of diminishing marginal returns. So colleagues, remember this. When marginal product is increasing, I think I typed this out. When marginal product is increasing, let me just put it in. Yes, when marginal product is increasing, total product is increasing at an increasing rate. Okay, that's what we're saying. These increasing returns. It means total product is increasing at an increasing rate. Okay. Then when marginal product starts to drop, total product is increasing at a decreasing rate. Okay, this is where we're talking about the diminishing returns. This yellow part here, this is the point where marginal product has started to drop. Okay, so as you add in more workers, when your capital and your land are fixed, your marginal product will start to drop, and then eventually your total product is going to drop. That's the law of diminishing marginal returns. Okay. You must remember the short run and the long run in economics. The short run, when one of the factors of production is variable, while others are fixed. Colleagues, what are these factors of production? And entrepreneurship. Okay. Yes. So, when your land and your capital is fixed, and you keep bringing in more workers, eventually your marginal product will reduce, then your total product is going to drop. Okay. Which brings me to the final point. As marginal product continues to drop, total product drops. Okay, and this is the red line, negative returns. Okay, colleagues? That's the law of diminishing marginal returns. The more variable units you bring in while you've got fixed units, marginal product will eventually drop, then total product is going to drop. Okay, it's marginal product that drops first, then total product now follows suit. So please remember this relationship also. Mhm, mhm. Decreasing and what? Okay, to make life easy. Oh, let's make life easy. I don't know why I put drop there, but yeah, decrease. When marginal product is zero, what does this imply for the firm's production? So first thing I would ask, what does it mean? I wouldn't say per se, but I would say the output would drop. Not I wouldn't say no more output, but output is going to continue to drop as you bring in more workers. Maybe if you put it that way, Mr. Chimonji. Output continues to drop the more workers you hire in. Okay. The company will be producing something, but they'll be at that point. Oh, before I finish answering the question in entirety, just hold on. Hello? Okay, okay, let me send. All right, colleagues, let me just send one thing. Just give me 2 minutes. As I'm sending this thing, yes, colleagues, what does that imply when marginal product is zero, apart from total product dropping? Yes, saturation point. Okay, basically here, when marginal product is zero, it means the next workers you bring, they're not bringing any additional output. All right, they don't bring any additional output. You have more workers on very few machinery, so eventually your total product is going to go down. Okay, many workers on maybe one machine, the machine breaks down. You have to wait for someone to come and fix it. Time is going. At the end of the day, you produce less. All right. So when marginal product is zero, total product is going to continue dropping, and each worker that comes in is not going to bring in additional output. Hiring a new worker is going to be suicide. Yes. Any questions before we go to part 5? Explain the concept of diminishing marginal returns, which I've already explained. Can someone just explain it one more time so that the masses remember it? The more workers a firm hires when its other factors of production are fixed, which are land and labor. Land and capital, not land and labor. Land and capital. The marginal product, meaning the additional product each worker brings in. The additional output each worker brings in will start to reduce or to decrease or to drop, and eventually the total product will reduce. Are we okay with that, colleagues? We can go to question two. Madam Alinawe, are we okay with that? Madam Betha, are we okay with that? Mr. Emmanuel, Mr. Kasono, Madam Lillian, Madam Piri, okay, Mr. Chimonia, Madam Sylvia, okay, Mr. Trevor, Mr. Vincent, and Madam Yvonne. Okay, so question two, compare and contrast the profit maximizing conditions both in the short run and the long run for a perfectly competitive firm and a monopoly. Okay, this topic, we just looked at it this month. Yes, so what are the differences in terms of the profit maximizing conditions for a perfect competition and a monopoly? Eesh. Mr. Kasono, sir, we did this topic just last week. Yes, not the definition of perfect competition. Mhm. Although, okay, a good way to start this, because maybe for those who are not there when we looked at the perfect competition, is perfect competition. This is where sellers are selling homogeneous goods, similar goods. Okay, think of people selling broiler chickens, people selling tomatoes. Okay, the agricultural sector is a perfect example. All right. What's another characteristic of a perfect competition apart from homogeneous goods? Identical is okay. Identical, homogeneous, same goods. Okay. Yes, they are price takers. Let me write this down so that Everyone remembers this because market structures are coming, definite. They never miss. So, characteristics, um, s- similar goods sold by everyone. Or everyone sells the same goods, homogeneous goods, identical goods. Firms are price takers. Okay. What else? Yes. Easy entry and exit. Okay. Today, if you want to start selling tomatoes, you can start. You just get a box and find where to sell. And the day you want to stop, you can stop. Okay. Easy entry and exit. What else? At least four. Yes, perfect information. So meaning what? Yes. Customers are knowledgeable. So one seller cannot croak a customer and make them charge them over because the customer knows the price. Okay. Yes. And many firms. Okay. Colleagues, these are the basic characteristics of a perfect competition. All right. Why is this line straight like this? For those who are paying attention in when we looked at this, why is the line straight like this? Yes, and also if any firm to sell more goods, you cannot change the price. Okay, so meaning if you want to, if you are selling chickens, if you can sell 50 chickens, you still sell at the same price. You cannot change the price. If you sell 100 chickens, it will still be at the same price. You try to sell 150 chickens, still the same because you are a price taker. And the moment you try to charge above, you try to go above, you're going to lose probably 90% of your customers. So, no matter how many units the firms want to sell, they cannot increase or decrease the price. They have to sell at the market price that has been given to them. Okay, so when you're drawing this graph, you can start with this one. Remember, marginal revenue equals demand, which equals average revenue, which equals price. Okay, we draw the marginal cost curve. Colleagues, why is the marginal cost curve shaped like this? Thank you. Yes, due to the law of diminishing marginal returns. Okay, then after you draw that marginal cost curve, then you draw your average total cost curve, right? Always make sure, because remember, where marginal cost cuts the average total cost, that's the minimum average total cost. Okay. So when you're drawing this average total cost curve, make sure that's like the minimum, then it comes like this average total cost curve. Here, you also need to draw the average variable cost curve because they might ask you about the shutdown rule. Colleagues, what is the shutdown rule? colleagues. Where all the s- I'm asking for the point. Somehow, yes, when all these curves are above this demand curve, especially when the average variable cost curve is above the demand curve, then you know you have to shut it down. So now I'm just saying what what is that what is that point basically? Or how do we write it? Mm-hmm. Okay, let me when P is less than AVC. Okay. Or basically when your average revenue in simple terms, when you cannot cover your variable costs, okay, that's when you shut it down. When you cannot cover your variable costs, and that will be the point where this demand curve, this red one here, is below. It means here you cannot cover your variable costs, okay. Then you need to shut it down. So just in case you are told to illustrate that point. Here, although in this question, they're telling we're talking about the profit maximizing conditions in the long run and in the short run. So for a perfect competition, can it make profits in both the long run and the short run? And for a monopoly, can it make profits both in the long run and the short run? And then you need to draw graphs to show that. So, colleagues, in the short run, can a perfect competition make supernormal profits? Yes or no? Yes. And in the long run, first we show that in the short run in the graph here, okay? So in the short run, look for the point where, with these graphs, okay? Look, first point you look for is where marginal revenue equals marginal cost. This is the point of profit maximization, where marginal revenue, additional revenue equals marginal cost, additional cost. All right. So this point where MR equals MC, as you can see here, it's here. Oh, wait, that's not the point. Yes, it's here. Okay, because remember this red line, which is the demand curve, is also the marginal revenue. So this is where MR equals MC. So once you find that point, you start dropping it down. You draw an arrow here. Where this line touches your average total cost, you take it here and you say here ATC. On top here you put price, that's ATC. Then you continue to bring this line down. Okay, if you want where it touches average variable cost, you can put it there, but it's not necessary. Okay. Then you this is the quantity that's being produced. And this line here, or here where I'm shading, this box represents the profits in the short run. Okay, this box represents the profits in the short run. Okay. Any questions? Then now, in the long run, since people have seen the firms are making supernormal profits or positive profits, some books even say abnormal profits, they start entering in. They start entering into the market. And as they enter in, remember, there will be more supply of whatever good they are selling. So when there's an abundance of goods on the market, price of that good goes down. Price of the good goes down. Okay, so in the long run, you draw it like this. This is ATC, MC. And always remember, always put these labels here, because if you miss them out, you lose out points. So always put here. Marginal revenue equals demand, which equals average revenue, which equals price. So the point of profit maximization, again here, where marginal revenue and marginal cost are intersecting. Okay, then once you start to drop in your point, so this line has already touched the average, the demand curve. So here on this part here, you're going to say P, which is price, equals ATC. P equals ATC. Then this is not perfect competition in the long run. Okay. In the long run, there's no positive profits or abnormal profits or supernormal profits. Any questions? It's perfect competition, yes. You have to draw two graphs. Or ABC. ABC, you can put it there. Yes, Mr. Kasono, you had a question? So, either way, you won't be penalized. Okay. The reason why I didn't put two, I want everyone to see the difference. Okay? If I put one, okay. Okay. If you have those ones, please show me so that I can break them down to you. Okay. But yeah, the reason why, as I said, so that you can differentiate. The one above is in the short run, the one below is in the long run. Okay. Yes. Mm-hmm. Okay. I need to see these graphs because I've got no idea. Okay. Okay, now I have an idea. Is it the one where there's a supply and demand graph on the side also? Okay. 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 You want me to draw it? Huh? Okay. Okay. All right. Then for a monopoly, because with this question, you're comparing and contrasting the maximization in the long run and in the short run. So for a monopoly, you just have one graph to draw. Yeah, this one, marginal revenue is here. Why is marginal revenue falling twice as steep as average revenue? It's become quiet again. Colleagues, it was people who were talking, it was nice, then it's become quiet again. Why has it become quiet? Okay. The way I'm drawing it, that's how you should draw it, colleagues. Okay. Start with this average revenue demand graph. Okay. Inelastic. Monopoly, remember, it's inelastic. Okay. Because there's one seller only. Right. In monopolistic competition, it has to be slightly elastic because remember, there in a monopolistic competition, there are substitutes. So if this one wants to charge you high prices, you go to the other one. That's why demand is relatively elastic. But here in a monopoly, one seller and the only one selling that good. So demand for that good is inelastic. And if we remember, what is the relationship between total revenue and inelastic demand? If your good demand is inelastic and you want to increase your total revenue, what will you do? And after we answer that, also we have to answer why is this marginal revenue slope is the slope is twice as steep as the average revenue graph. Mr. Nchimonia, Madam C, productive efficiency for which one? You can tell us the question you're answering, then you say, I posed, okay, I posed two questions. First question is why is marginal revenue sloping? The slope is twice as steep as average revenue or price. And the second question is if you know that demand for your good is inelastic and you want to increase your total revenue, what would you do? Everyone was there yesterday. Mm-hmm. Wonderful. That's correct. Yes, that is correct. So a monopoly, then if they want to increase their total revenue, just increase the price. So, then why is second? Mm-hmm. Now you can go ahead, sir. Wait, you're not. What were you saying, Mr. Gasono? Have you answered the question or? That's true, yes. If you reduce the price, most likely your total revenue will drop. Increase the price, most likely. Notice I'm saying most likely. It's not always the case, colleagues. Okay, it's not always the case. Okay, when all factors are held constant, you increase the price, total revenue will increase. If you reduce the price, total revenue. Yes, so that you want to make it as precise as possible. Okay? So all factors being yes. Now the other question: why is this one slope? So the slope is twice this one here. Okay, that would be your homework. Okay, that would be your homework. We can move to the next part. Yes, this question here, right? You are given the following data concerning the production costs and the average revenue of a profit maximizing firm that produces good X. A fixed cost of production are 100 kwacha. Given the table below, calculate total variable cost, total cost, marginal cost, marginal revenue, profit and loss at each level of output. Colleagues, these are the formulae you need to remember before we start attempting that question. These formulae here. Okay. Once you just remember for average, okay, just remember for the average, that's all, and you'll be home and dry. Average fixed cost, total fixed cost over quantity. So if you want to get total fixed cost, you just make it the subject of the formula here. Average variable cost, total variable cost over quantity. Average total cost over quantity. Average revenue, total revenue over quantity. Please write these down. Just remember, if it's average, it's a total over Q. Okay, Q is the denominator. So write these down. Yes. Then also remember this basic one, total fixed cost, also TFC or TC, total fixed cost is total cost is total fixed cost plus total variable cost. Next year in cost accounting, We are going. These are the first things you'll be looking at here in cost accounting when you're looking at cost behavior. So remember these formulas so that next year, once we start, you're not getting confused. Okay. After you have done that, we now come to this step. Okay. So what element should we put in first here? Because in the day for the exam, you'll be alone, so you need to know you'll be confronted with this table. So you have to know, okay, what should I put in first here? Think of it right now, you're writing the exam and you've seen this table. Okay, then. Yes, you can put, yeah, you can put total variable cost. Let's put total variable cost first. Although I wanted to put fixed cost also. So you can start with either, okay? TFC, total fixed costs. I think let me use Excel for this one. Mm-hmm. Yes, in an instance, mm, you look at the output and you see the output is zero and you find the total cost put there. That total cost when output is zero is your fixed cost. Okay, you will see something here, madam. You see it like this on the table. You see output zero. Okay. Then you see on total cost, you see a figure like 100 there. Okay. Then they won't tell you that fixed costs are 100. It's you to remember that fixed costs are still incurred even though your output is zero. So whatever total cost you're given when your output is zero, that is your fixed cost. Is that okay, madam? Are you there, madam? Yes. When the out, yes, you can continue. Yes, yes. You look at your output, you see output is zero. And then you look at your total cost column, you see a figure there. So if you see that figure of 100, then you know that, okay, that is my fixed cost. Because you need to remember the cardinal rule fixed costs, you incur them, even though you're not producing anything. For example, if you're a factory and you're not producing anything, you still need to pay rent. Yes. So then variable costs, these are costs dependent on output. That's why that 100 there, when output is zero, there are no variable costs incurred. Okay. Direct materials, direct labor. Remember in manufacturing accounts? Those direct material, direct labor, those are the variable costs. Yes. So colleagues, take note of that. Okay. Sometimes they won't tell you this is the fixed cost. You just have to look at the output and say, okay, the output is zero and there's still a cost being charged. That's the fixed cost. Okay, yes. So as I said, let me put this on Excel. I wish in the exams they could allow you to be using Excel to make life easy. Okay, yes. So fixed costs. It's 100. Okay. Then we can get our variable costs. Okay. Total variable cost, same thing. Okay. Variable costs. So how do we get our variable costs? Because this formula, as I said, the formula which I told you to write down, they won't be given to you. So you need to remember them. How do we get our variable? Yes, colleagues, average variable cost times output. Okay, we derived the equation from, where is this he? Okay, average variable cost, total variable cost over Q. So I want to get this TVC, total variable cost. So I'm multiplying Q times our average variable cost. So here for one, average variable cost 110 times output 1. Hmm? 110 times 1, one's no, that's why I never said multiply. I was about to be surprised. Okay, the next one, 95 multiplied by, we're just multiplying average variable cost times output. Okay, we're just focusing on these two columns here. Okay, yes, 80 times 3, 240. Any questions? All right, what item comes in next now? Total costs, yes. And how are we getting our total costs? Thank you. Thank you. Okay, colleagues, we are focusing on these two columns here. Yes. We're applying the formula I told you to write down. They are the ones we're applying here. Okay. Yes, total cost, you just add fixed plus variable costs. What comes next? We can start with marginal cost. Yes. So for 1 unit, what is our marginal cost? Marginal cost, marginal product, marginal revenue. They all have the same formula. Okay, they all have the same formula. It's just what is on the numerator which changes. Okay, so for marginal cost, it's change in total cost over change in output. So what is our first marginal cost here, Mr. Chimunya? 210, yes. The next one, you said 210, 290 minus 210, you get 80. Next one, 340 minus 290, you get 50. 400 minus 340, you get 60. 510 minus 400, 110. 610 minus 510, 100. 730 minus 690, 120. Yes. Any questions? What is the next item? Not marginal revenue. How do you get marginal revenue when you don't have total revenue? Mr. Chimunya, you also said marginal revenue first. Okay. So, total revenue, how are we getting it? 900 minus 730. Yes, let's see. Oh, 170, huh? You are paying, oh, you are paying attention there. That's good. Yes. How do we get total revenue? Hmm. Yes, it's price times quantity. That's true. But in this question, I don't think they gave us price. No, this is a fixed cost. Mr. Chimunya, just say it again. You are correct with what you said. Yes, yes, yes. We use this one here. Average revenue equals total revenue over Q. Okay. If there's no price, you use this formula. Okay. But if there's a price given, it's just price times quantity. So average revenue times quantity. Is anyone dozing? How are you lost? This is easy. How are you lost on this one here? These are the okay. Okay. Yes. So average revenue times why is it done that? Times quantity. 70 times 10, 100, 80 times 9, 720, 70, 100 times 7. Okay, so we've got our total revenues. Then what next? Marginal revenue, right? So first marginal revenue is going to be 300. Next one, 500 minus 300. Then 630 minus 500. Then 720 minus 630, right? Remember, marginal revenue, marginal cost, marginal product, same formula. Okay, same formula. Yes. Any question? Marginal revenue, marginal cost, marginal product, same formula. Mm-hmm. Yes, yes, yes. It's not given there, but they've asked for profit or loss. So as you said earlier, you just put it. Because trust me, if you don't put it there, you reach profit there. Now you're wondering, well, how am I getting my profit? And what's the formula for profit? Back to accounts. So I just say total revenue minus total cost. Total revenue. Yes, you can do average revenue minus average cost. Have we got average costs here? We haven't got average costs. Yeah, you can do average revenue minus average cost. Average total cost, that is. Okay. So total revenue minus total cost. So we're getting our profits. Total revenue minus total cost. Yes. Any questions, colleagues? We're doing change in total revenue. So I was just subtracting 500 minus 300, 200. 630 minus 500, 130. 720 minus 630, 90. 750 minus 720. How did 301 come in? Yes, 750 minus 720, you get 30. Is that okay, madam? Yes. The same will apply also for marginal cost. Change in total cost over change in quantity. Now remember, change in quantity is increasing in units of one. So our denominator throughout is always just going to be one. So in the exam, I don't think you have time to be writing for each section here. You would put the formula. You put the formula. What you can do is on your answer sheet, you write the formula. Then you just put the figures. Because if you do that, where you're writing the formula and showing all the workings like that, time would have gone, and you would have found maybe that's the only question you've answered. So unless maybe if it's 100 marks, then yes. But if it's not, it's going to come. Prepare for that. Mm. And worse if it says compulsory. Yeah. Mm. So if it comes compulsory, should you skip this one? I remember for that linear regression and so if this one comes compulsory, should we skip it? So even this one, if it comes compulsory, please don't skip it. Determine it will come like this. Um, I think when we'll be looking at past papers, we might see it even. This one came in, she gave this one as, it was also an assignment question in 20, not mistaken, 2022 or 2021. She gave this assignment question. So if you check on the past, oh, um, okay. So the probability is low then, huh? So why didn't you tell me to skip it then? It's not coming. Okay, yeah, there's a probability. Okay, yeah, yeah, actually, yes. There can be a probability that she can repeat it again. Because remember, making new questions is a process. Lecturers don't want to be making new questions. Better they recycle them. It makes life easy for them and marking. Okay, next part, determine the profit maximizing level of output. Okay, so first you have to look for in your table, is there a point where marginal cost equals marginal revenue? Okay, so marginal cost here, let's highlight marginal cost blue here, marginal revenue also eat blue. Then we come and compare. Is there a point where they are equal? So there's no point where they're equal. So if you don't find that point where MC equals MR, do you know what to do next, colleagues? Before I tell you what to do, once you find there's no point where MC equals MR, what do we do next? You can't say that there's no point of there's no profit maximization because there is a maximum profit. So what do you do next, colleagues, if you don't see where MC equals MR? You just yes. No, but what you just do is just come to the profit and say, okay, which one's the highest profit? The highest profit is 320. Then, as you've said, sir, the number which looks closer to each other, here 60 and 90. I think these are the closest. I'm not yes, these are the closest to each other. Okay. But you just come in the profit section and say, okay, where is the profit the highest? So this firm makes the most profit at when they produce 4 units. Okay, so this firm should produce 4 units. Okay, part C. Now, this part C, and they say this part confused me. Colleagues, they did not find a solution for this part. Me, I got confused on this one. And I remember I left it. I said, I'll look at it another time. Did anyone find the answer for this one? No. Okay. You give me time to review it. We can go to part D. I can review it. I can face maybe after the class ends. I'll try to review it. Okay. But remember, the point where you cease production in the short run is when your total revenue cannot cover your variable costs. Okay. This is the same shutdown rule here, where your revenue cannot cover your variable costs. So I think maybe first you have to look for where you compare where total revenue and variable costs, and then maybe you see, okay, if I increase the variable costs by this amount, does it mean that total revenue will fail to cover this? I think maybe it's in those lines, but I'll get back to you on that one. Is that okay, Mr. Chimonia? Madam Sylvia, is that okay? Madam Yvonne, is that okay? Mr. Vincent? Oh, okay. Your community newspaper, The Express, has fixed production costs of 70 kwacha per edition and marginal and printing distribution costs of 40 ngwe per copy. The X Express sells for 50 ngwe per copy. Write down the cost, revenue, and profit functions. All right, first things first, you're going to assign Q to be the number of copies. Okay, Q is an easy number, is an easy letter to for when you're talking about quantity. Okay, I wouldn't advise using any other letter. You can use X, but usually in economics, I would advise you use Q. Okay, so you say, okay, Q will represent the number of copies, right? The price, 15 ngwe, you can convert it into kwacha because you'll be dealing with kwacha here. So 15 ngwe into kwacha into 100. When you're converting ngwe to kwacha, you divide by 100. So 50 divided by 100, 0.5. Then we can now start with our functions. Our cost function, remember, total cost equals fixed cost plus variable costs. Our fixed cost is 70 kwacha. Our variable costs 40 ngwe per copy. So you put 40 ngwe into kwacha, 0.4. Yes. So you put 0.4 Q. Any questions on the cost function? Mm, repeat from where? Where should I start from? Fixed cost, 70 kwacha. Variable cost, they told us 40 ngwe per copy. So 0.4 Q, since Q is number of copies. Is that okay, Mr. Kasona? Okay. No, you're a mathematician, so this shouldn't be hard for you. Okay, so remember, cost function is just total cost plus not total cost, fixed cost plus variable cost. Okay, for cost function. Revenue function, price times quantity. Okay, price times quantity. Okay, so our price 0.5, 15 ngwe per copy. All right, our quantity is Q, so 0.5 times Q. Any questions? Is this consumer friendly? Mr. Vincent, consumer friendly? Madam Sylvia? Mr. Chimunya? Madam Perry? Madam Lillian? Yes. Colleagues, those formulae we're doing on that table, they're also applying here. So that here now we're doing algebra. We're bringing in letters. Okay, but those formulae still stand. Okay. Total cost, fixed cost plus variable cost. Total revenue, price times quantity. Profit. What about for profit? Which one are we going to use? Mr. Chimonya, which one are we going to use for profit? Yes, total revenue minus cost. So you say revenue minus cost. 0.5 Q minus, put in brackets, 70 plus 0.4 Q. I repeat, colleagues, always put this one in brackets and distribute the negative sign. Okay, don't just leave the answer like this. like that, and you say you're done. No. Okay, according to the laws of algebra, okay, if you've got a binomial, okay, binomial two terms, you put a bracket. Okay, then you distribute the negative sign. Negative times 70, negative 70. Negative times 0.4q, negative 0.4q. Are we all okay with that? Then you group like terms. Okay. 0.5q, remember like terms according to algebra, same variable, same power. Okay, like terms, same variable, same power. So those doing BBA, third year, if you don't like mathematics, please start loving it now. 0.5q minus 0.4q, 0.1q minus 70. That is the profit function. Now let me add my. Uh-huh. Uh-huh. It's okay. Where is what coming from? Where the cement is, it's a fixed cost. So here's my question now. What is the marginal cost and what is the marginal revenue? Or how do we get the marginal cost and how do we get the marginal revenue? Let me see in the question if that's part there. How many copies should they break even? Okay. So we'll come to that in part D. How many copies should they sell to maximize profit? I've added this one here. So here, part C, it says, how many copies should they sell in order to break even? Colleagues, what is break even? What is break even? Correct. The point where there's no loss or no profit. Okay. Or the point where your total revenue equals your total cost. Okay. So you can either use either this one, you can say break even is the point where profit equals zero. You can equate the profit function to zero. You find the quantity. Okay. We say profit equals zero. Or you can use the point where total revenue equals total cost. Okay. You're supposed to find the same answer. Oh, wait. Oh, there was a part B. Let's see part B. Did I skip? Or what profits or loss results from the sales of the express? Okay, I skipped part B. So for part B, it's just simple. Where there's Q, substitute it with 500. Okay, before we come that point. Yes, where there's Q, substitute it with 500. Okay, so 0.1 times 500, 50. 50 minus 70, they make a loss of 20 kwacha. Yeah, they make a loss of 20 kwacha. This profit function is it helps the firm make and plan, make decisions and plan. So here this firm says, okay, if we produce, this is our profit function. If we produce 500 copies, we'll make a loss. So as as a managerial economist in the business, what would you tell the firm to do? If you see that if they make 500 copies, they'll be in a loss, what will you tell the firm to do? You tell them to make more than 500 copies. Okay? Because you know if you make 500, you're in a loss. Then the next one is how many copies should the firm sell to in order to break even? Okay, so we used the total revenue equals total cost. Total revenue, which fun? No, we use the profit function equals zero because 0.1q minus 70 equals zero. So this is the one I used here. Okay, colleagues, where profit equals zero. So 0.1q minus 70 equals zero. Like terms, so we take this negative 70 over the equal sign, it becomes positive. So you have 0.1q equals 70. So to find the value of q, you're going to say 70 divided by 0.1, 700. So what this tells the firm, that if you make 700 copies, you're going to break even. So what would you tell the firm to do then? Mr. Chimonia, you're the director of finance. You made a profit function for your firm, and you find out if they make 700 copies, they'll break even. If they make 500 copies, they'll make a loss. So what would you tell the firm to do? Yes. Yes. So that's why now I've brought the second part. How many copies should the firm sell to maximize profit? Because then we just know we have to make above 700, but we have to know, okay, but above 7, does it mean just 800, 900? So we ask, okay, in order to maximize profit, how many units will we sell? So now, this is where we remember the profit maximizing condition, where marginal cost equals marginal revenue. So I'll come back to now my question. Colleagues, how do we get the marginal cost and the marginal revenue? Mm-mm. Because you have a lot of possibilities, because you have to find what will be your TRR1, your TRR2. There will be many possibilities, so you won't be able to find. What you're supposed to do is you're supposed to derive the cost function to get the marginal cost, and you have to derive the revenue function to get the marginal revenue. So if we derive this cost function, what do we get? Back to business mathematics and statistics. Unit 8 of the module calculus. So if we derive, what would we get? Remember, deriving, you multiply the exponent by the number in front of the letter, which is called the coefficient. 1 times 0.4, 0.4. Then you subtract a 1 from the exponent, which is just the power on the q variable, or the letter q. Why is this not right in here? Okay, you subtract a 1, so you have 0.4q to the power 0. Remember, anything to the power 0, it disappears. It's 1. This 70 also disappears. Okay? When deriving, if a number doesn't have a letter, that number disappears. So when you derive this cost function here, you're going to just get 0.4, which is your marginal cost, which means if you produce an extra unit, it's going to cost you 14 ngwe. Produce another unit, 14 ngwe. Any questions on that deriving? Here, for marginal revenue, you have to derive this function here. So 0.5q. So this is 0.5q to the power 1. Yes, 0.5. Yes. Exponent multiplied by the coefficient 1 times 0.5, 0.5. Then you subtract a 1 from this exponent here, you get 0.5q to the power 0. And q to the power 0 is the same as 1. Now I see why the madam never put this question, because these these two don't have a variable. So if you equate this to 0.4 to 0.5, you're not going to find the value of q, because this 0.5 and this 0.4 do not have a q attached to it. So that's why that wasn't put. So with this question, it's be very hard now to tell how many units you need to sell in order to maximize profit. But that's what you do when you're trying to calculate how many units you need to maximize profit. Equate marginal cost to marginal revenue, then you solve for Q. So here we're not able to solve for Q because our derivatives never had a Q, they're just whole numbers. Any questions before we move to the last part? If So what I was trying to illustrate in that question is going to happen in here. A firm faces the following linear inverse demand for its product P equals 60 minus 2Q. Find the firm's total revenue. You're going to say total revenue. Total revenue. Mm-hmm. Total revenue price times quantity. Okay. So price here is 60 minus 2Q multiplied by Q. Okay. Always when you're getting to total revenue, just leave Q as it is, just like that. So when you multiply Q times 60, 60Q minus 2Q times Q, 2Q squared. This is your total revenue function. Any questions? Consumer friendly, right? Well, mhm. Okay. So they want us find marginal revenue. So marginal revenue we derive. So colleagues, let's derive this one. I illustrated earlier how to derive. So let's derive this. And you assured me, sir. Mm-hmm. Not disappear. Not. No, no, no. I'm saying that the second one, the second one won't the one with the Q squared, that one's not disappearing. That continuous or no, you're in the correct path. It's just the terminology. Mm. Kylie, when it's yes, yes, 60 minus 4Q. Colleagues, are we all okay with this? Is everyone okay? Okay. Madam Betha, Madam Lillian, okay, Madam Betha, Mr. Emmanuel. Okay. Madam Lillian, Madam Piri. Okay. Wonderful, wonderful. Okay. Madam Sylvia, I know since you answered already. Madam Yvonne. All right. And after we've done that, let's see. Well, Yes. So, assuming the marginal cost of production is given by MCA, what will be the equilibrium output and price? So here, that's basically just talk about where MC equals MR. Okay? Where marginal cost equals marginal rate. Yes. So this equilibrium, they're talking about where marginal cost equals marginal revenue, point of profit maximization. So marginal cost has been given as 8. Marginal revenue has also been given 60 minus 4Q. So equate them and find the value of Q. Just excuse me. As you are solving, just excuse me. That's marginal revenue, yes. So equate it to 8. 8 equals 60 minus 4Q. Take the negative 4 so it becomes positive. Take the negative 4 over, and this 8 also take it off. If you want to, so this one should go this side, and the 8 should come this side. Or if you want to leave the negative 4 here, you can take the 60 that side. You get two negative values, then they'll cancel each other out to make positive. Yes. Yes. So this firm needs to produce 18 units to maximize profit. Okay. They want to maximize profit, they need to produce 13 units. Then they also want us to find the equilibrium price. So price, remember, it is 60 minus 2Q. So substitute 13 into this expression here. So it will be 60 minus 2 times 13. Sixty minus 2. Oh, yeah, minus 2Q. And 60 minus 2 times 13. Okay, what do we get? Oh, 26, oh, not 36. Yes. So the price they're charging, they should charge is 34 kwacha. And to maximize profit, they need to produce 13 units. Yes. So this is what I was trying to illustrate in that question previous. Now you can imagine. Mhm, 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 mhm. Yes, because the equilibrium, remember, is a point where two things are equal to each other. Okay. So there, the two things that are equal to each other, it's